welcome back to SN Matrix Arithmetic Sequence Part 5. In this session, we mainly discuss more about sums and terms of arithmetic sequence. Once again, welcome to this session. Let's consider an arithmetic sequence starting with the 5, common difference 3. Here I take the pairwise sum. For this, take the first and sixth term. What is the sum of first and sixth term? That is 5 plus 20 equal to 25. Next, consider second and fifth term. x2 plus x5. What is the sum of second and fifth term? That is 8 plus 17 equal to 25. Next, take third and fourth term. x3 and x4. What is the sum? 14 plus 11. 11 plus 14, that's again equal to 25. Now we notice that the sums are equal. We also find the sum of the positions. What are the positions? First we consider the first and sixth term. Then position sum 1 plus 6, that's equal to 7. Next 2 plus 5, that's equal to 7. Next 3 plus 4 is also 7. That is, position sum is also equal. That means if position sums are equal, then term sums will be equal. What is the conclusion? If position sums are equal, then term sums will be equal. In general, we can write it as, in an arithmetic sequence, if sum of positions of two pairs of terms are equal, then sum of the pairs of terms are also equal. That is, in short, if position sum is equal, then term sum is also equal. That is in brief. Okay. Next we consider the arithmetic sequence 3, 5, 7, etc. Here we find the sum of first 5 terms, 3 plus 5 plus 7 plus 9 plus 11. That is by formula 5 by 2 into 3 plus 11. That is 5 by 2 into 14. 2, 14 get cancelled. Then 5 into 7. That is 35. It is very simple. By formula we got sum is 35. From this sum, I conclude one thing, that 5 is number of terms, and what about this 7? 7 is middle term of these 5 terms. So in general, we conclude that sum equal to number of terms into middle term. If number of terms are odd. If number of terms are odd. That is, in general, sum of any odd number of terms of an arithmetic sequence is number of terms into middle term. That is, sum of first 3 terms equal to 3 into x2, and sum of first 5 terms is 5 into the middle term. What's the middle term? Third term, x3. And sum of 7 terms, s7 equal to 7 into x4. And so on. We can write it as, if number of terms n is odd, then sum of n terms equal to, sum of n terms of arithmetic sequence is n into middle term. If sum is given, then middle term is sum divided by number of terms. Let's consider some problems. Write three terms, first three terms of the arithmetic sequence if first term is 30, sum of first three terms is 300. First three terms, that is x1, x2, x3. Sum is given, a number of terms is odd. So the middle term x2 is sum divided by 300 divided by number of terms. That's equal to 100. Also given the first term is 30, that is x1 equal to 30. Then we can find the common difference d equal to second term minus first term, that is 70. Using second term and common difference, we can find the third term, that is second term plus common difference, that is 170. Therefore, first three terms are, first term is 30, second term x2 is 100 and third term is 170. Write the first three terms of an arithmetic sequence if first term is 30 and sum of first four terms is 300. Here given sum of first four terms, that is x1, x2, x3 and x4, its sum equal to 300. We know that x1 plus x4 and x2 plus x3 are equal. Therefore, x1 plus x4 equal to 300 by 2. There are two pairs. 300 by 2 equal to 150. Given that x1 equal to 30, then 30 plus x4 equal to 150. Therefore, fourth term is 150 minus 30, that is 120. Now, the first term is 30 and fourth term is 120. Then we can calculate common difference, that is term difference divided by position difference. 120 minus 30 divided by 4 minus 1, that is 90 by 3 equal to 30. Now we got the common difference d equal to 30. Here the first term is 30. Given that first term 30, then first three terms equal to 30, 60 and 90. Write first three terms of the arithmetic sequence if first term is 30 and sum of first five terms is 300. Here the first term x1 equal to 30 and sum of first five terms is given. Then the middle term x3 equal to sum divided by number of terms, that's equal to 60. Also we know that if a, b, c are three consecutive terms of an arithmetic sequence, then middle term b equal to a plus c by 2. Using this, here first and third term is given, then second term equal to 30 plus 60 by 2, that's equal to 45. Therefore, first three terms 30, 45 and 60. Write first three terms of the arithmetic sequence if first term is 30 and sum of first six terms is 300. Given that first term is 30 and sum of first six terms is 300. If we consider first six terms, there are three pairs of terms and sum of each pair is, that is x1 plus x6, that's equal to 300 by 3, that is 100. We take by 3 because there are three pairs and sum of each pair is equal. Therefore, x1 plus x6 equal to 100. In this, x1 equal to 30, then it becomes 30 plus x6 equal to 100. Then what about x6? That is sixth term. sixth term x6 equal to 100 minus 30, that is 70. Now the sixth term and first term is known. Using these two terms, we can find common difference. How to find common difference? Term difference divided by position difference. That is D equal to x6 minus x1 divided by 6 minus 1. That is 40 divided by 5, that's equal to 8. Here first term is 30, common difference is 8. Then we can find second term, that is 30 plus 8 equal to 38. Then third term equal to second term plus common difference, that is 46. Therefore, first three terms are 30, 38 and 46. Find the sum of first 25 terms of the arithmetic sequence 11, 22, 33, etc. Let's see the answer. Here first term f equal to 11 and d also equal to 11. We have to find the sum of first 25 terms, then x 25, that is f plus 24 times common difference. That's equal to 11 plus 24 into 11, that is 11 plus 264, that's equal to 275. Now the first term and 25th term is known. Then using this, how to find sum of first 25 terms? Everybody knows the answer. What's the formula to find sum? Yes, n by 2 into first term plus last term, right? Then S25, sum of first 25 terms equal to 25 by 2 into f plus x25. That is 25 by 2 into f is 11 plus x25 is 275. That is 25 by 2 into 286. That's equal to 25 into 143, that's equal to 3575. What is the difference between the sum of first 20 terms and next 20 terms of the arithmetic sequence 6, 10, 14, etc.? First we find the sum of first 20 terms. For this, the first term f equal to 6, common difference equal to 10 minus 6, that's equal to 4. Then 20th term x20 equal to f plus 19d, that is 6 plus 19 into 4, that is 6 plus 76, that's equal to 82. Now the first term and 20th term known, or using this we can find the sum of first 20 terms. That is S20 equal to 20 by 2 into first term plus 20th term, that's equal to 10 into 88, that is 880. Next we find the sum of next 20 terms. Next 20 terms means the terms begins from 21st to 40th. 21st to 40. What is 21st term? We know 20th term, that is 82, and common difference is 4. Then 21st term is 82 plus 4 equal to 86. Then 40th term x40 equal to x21 plus 19 times common difference, that is 86 plus 19 into 4, that is 86 plus 76 is 162. Then sum of next 20 terms. Sum of next 20 terms, that's equal to, here the number of terms is 20, then n by 2 become 20 by 2 into first term plus last term. Here the first term is 21st term and last term is 40th term, that is 86 plus 162. That's equal to 10 into 248. That's equal to 2480. Therefore, difference in sums equal to 2480 minus 880, that is 1600. Calculate the difference between the sums of first 20 terms of the arithmetic sequence 6, 10, 14, etc. and 15, 19, 23, etc. We first find the sum of first arithmetic sequence, then find sum of second arithmetic sequence, then take the difference in sums. For this, the first term f equal to 6 and common difference d equal to 4. Find 20th term, that is x20 is first term plus 19 times common difference, that is 6 plus 19 into 4, that is 6 plus 76, that's equal to 82. Then sum of first 20 terms, that can be denoted as S20. S20 equal to 20 by 2 into first term plus 20th term, that is 10 into 88, that is 880. For the second arithmetic sequence, first term is 15, common difference equal to 19 minus 15, that is 4. Then 20th term x20 equal to f plus 19 times common difference, that is 15 plus 19 into 4, that is 15 plus 76, that's equal to 91. Then sum of first 20 terms S20 equal to 20 by 2 into, here the first term is 15 plus 91, that is 10 into 106, that's equal to 1060. Difference in sums equal to 1060 minus 880, that is 180. Another method to find difference in sums is, here the both sequence have, the first sequence 6, 10, 14 and the second sequence 15, 19, 23, both have same common difference 4. So we find the difference of first terms. What is the difference of first terms? Yes, that's equal to 15 minus 6 equal to 9. Therefore, difference in sums equal to difference in first terms into how many terms? 20 terms into 20, that's equal to 180. That is the short method. Difference of first terms into number of terms. Difference of first terms into number of terms. That is 9 into 20. That's equal to 180. Find the sum of all 3-digit numbers which are multiples of 9. We have to find the sum of all 3-digit numbers which are multiples of 9. We know that the first 3-digit number is 100. But 100 is not a multiple of 9. 100 is not divisible by 9. So we think, what is the first number? By trial method, we can find 108 is the first 3-digit number which are divisible by 9. Therefore, f equal to 108 and d equal to 9. Then find the last term or nth term xn. We know that the last 3-digit number is 999 which are also divisible by 9. So xn equal to 999. This xn can be written as dn plus f minus d, that is 999. Substitute the values for d and f, then d is 9n plus f is 108 minus 9, that's equal to 999. That is 9n equal to 999 minus 99. That is 900. Therefore, n equal to 100. That is, there are 100 terms or 100 three-digit numbers which are divisible by 9. Now, we have to find sum of these 100 numbers. How to find the sum? Sn equal to n by 2 into f plus xn. That is 100 by 2 into f is 108 plus xn is 999. That is 50 into 7,011. By multiplying, we got 55350. 55,350. 4, 7, 10, 13, 16, 19, 22, 25, 28, 31, etc. Write the next two lines of this pattern. Calculate the first and last terms of 20th line. Let's see the answer. Here the first row contains one term or one number. Second row contains two numbers. Third row contains three numbers. Fourth row contains how many numbers? 4 numbers. So the fifth row contains 5 numbers and sixth row contains 6 numbers. How to find the number in fifth row? For this, the numbers are occurred in particular order. What is the order? If we add 3 to each number, that will give the succeeding numbers. Am I right? 4 plus 3, that is 7. 7 plus 3, that is 10. 10 plus 3, 13, and so on. That is, if we add 3 to the last number in third row, will give the first number in fourth row. Similarly, if we add 3 plus 3 to the last number in fourth row, will give the first number in fifth row. 31 plus 3, that is 34. Therefore, 34 is the first number in fifth row. What's the next number? 3 added. 34 plus 3, that is 37. Next 40, next 43 and 46. These are 5 numbers in fifth row. How to get the first number in sixth row? The last number in fifth row, that is 46, plus 3 will give the first number in sixth row, that is 49. Next 49 plus 3, that is 52. 52 plus 3, 55. 55 plus 3, 58. 58 plus 3, 61. 61 plus 3, 60. These are the numbers in fifth and sixth rows. Next we find the numbers in 20th row, the first and last number in 20th row. We know that the 20th row contains how many numbers? There are 20 numbers. How to find these numbers? For this, we consider the numbers as sequence. Then we got 4, 7, 10, etc. It is an arithmetic sequence, and the first term, that is f equal to 4, and common difference d equal to 3. The 20th row contains how many terms? 20 terms. To find these terms, we first of all consider a formula. We discuss what's the formula. The last number in nth row is dn into n plus 1 by 2 plus f minus 2. It is the formula to find the last number in nth row. It is compared to the general term of arithmetic sequence dn plus f minus d. We replace n by n into n plus 1 by 2. Then we got the formula thus. What is it? dn into n plus 1 by 2 plus f minus d. Therefore, the last number in 20th row, then n changes to 20, then formula changes as 3 into 20 into 21 by 2 plus 4 minus 3, that is 630 plus 1 equal to 631. That is the last number in 20th row. The 20th row contains 20 numbers. Number of terms in 20th row equal to 20. It's also an arithmetic sequence. So, the first number means we subtract 19 times common difference from the last number. Therefore, first number in 20th row equal to 631 minus 19d. That is 631 minus 19 into 3. That is 574. Dear students, the chapter arithmetic sequence ends here. I tried to discuss the chapter and explain maximum problems and variety problems through the videos. If you have any more doubt, please ask me personally or comment in comment box below. Thank you for watching my videos. Thank you, dears.